All right, guys, welcome AP class. Here we go. How to split a reaction. Now, what I mean by this is how we're going to balance a reaction, a redox reaction, which is a little bit harder than the normal balancing equations. So first, we've got to figure out how to split this reaction. First, we need to follow the electrons. And we need to find them first. So to find the electrons in this reaction, how they move back and forth, which is what these electrons do in a lot of these reactions, we got figure out how to find them. And to do that, we look at the changes in oxidation number. And this is why we went through all that last week, how to figure out oxidation number, molecules, and elements, because that's going to be important for this. So as we start, we got this reaction. And if you notice, we got, I need to change the color. As we're looking, while I change my pen, we have hypochlorite anion. Not hypochlorite, excuse me, chlorate anion, and we also have sulfur dioxide. They're going to react together to form sulfur sulfate anion and chloride, excuse me. And you notice that we have a charge imbalance too. So this is a -1 on the left and -3 on the right, and we're missing some oxygens and so forth. So we've got to figure out how this works. So to start, step 1, sign oxidation numbers. All right, so the easiest one, all these oxygens are bound to a different element, not to itself. So their oxygen is -2. So oxygen is going to be -2. So this is -2. This is -2. This is -2. So we'll cover that. This chlorine on the right is charged but not bound to anything. So that's its charge equals equals to the oxidation number. So it's -1. And so we have chlorine on the left to figure out, and the 2 sulfurs. All right, let's look at this guy. This is a neutral molecule. So for SO2, X plus 2 times a -2 equals 0. We need to figure out what X is. So this is how I like to figure these things out. And so this is a neutral molecule. The sum of the oxidation numbers have to equal 0. So X is equal to a -4. 2 times -2 is -4. And if you move it to the other side, X is equal to 4. So this sulfur is going to be a +4. And whoops, let me go back. There we go. So this sulfur is a +4. And I just lost my pen. Sorry, let me get this back. For some reason, it decided to be on automatic. So that's a +4. So what's the sulfur on this end? So when we're looking on the right-hand side, we got SO4 2 minus, or -2, whatever. It doesn't. It's all means the same thing. So X, we know there's just 1 sulfur, plus we got 4 oxygens. All of those are at a -2. And that's equal to a -2. So let's go ahead and finish up the algebra. 4 times 2 is -8. That's equal to -2. Add 8 to both sides. X is equal to 6. And so this is now a +6. All right, so we got sulfurs down. Now we're just missing this chlorine. So ClO3 minus. X, it's the same thing again. We don't know the chlorine, but we do know oxygen. That's 3 times the -2. And that charge on that anion is -1. So X, that -6 is equal to -1. So X is equal to 5. So this guy is going to be at a +5. And that is true because chlorine has electronegativity is less than oxygen, so oxygen is going to pull this. So when you look at these oxidation numbers, the one with the highest oxidation number is going to be more negative than the other. And that's true for here and here and here. All right? So if we have a halogen connected to an oxygen, that is going to force the chlorine to have a positive oxidation number. Okay, so I'm going to go to the next one, and we're going to, up on top, this is going to be +5. Go back, +4, +6, and -1. So these two differences is 2 electrons, so it's losing 2. So it lost 2 electrons. This guy is actually gaining 6 electrons, go from +5 to -1, so gain 6 electrons. And so here we have the separation of oxygen of our reaction. So this is going to be our oxidation reaction. So SO2 yields SO4, and this is going to be 2 minus, plus 2 electrons. So it loses 2 electrons, because we're going from a +4 to a +6, and that means 2 electrons are lost. This is nowhere near balanced. We haven't got there yet. But we won't get, that's for another slide, another video. So for the reduction, so this is oxidation, or OX, reduction, RED, we use the other two. This is how we split them up, ClO3 minus, and since it gains 6, we're going to add 6 electrons on the left, and it gives to Cl minus. So +5, +6 electrons from +5 goes to a -1, and now we have split a redox reaction, and we split it in half. So here's one half of the reaction, here's the other. Oxidation reduction. This is what we mean by splitting, and then we're going to show you later how to balance these things.